Assalamu alaikum dear student. Chapter 3, Dynamics Explaining Motion. We studied Newton's first law of motion. Now we will study Newton's second law of motion. So dear student, is in the start I told you Newton laws establish a relationship between the force, the mass and the acceleration in three quantities. Okay, so Newton's second law of motion deals with the situation when a net force acts on a body. This law deals with the situation when a net force acts on a body. In fact, this law establishes a relationship between the force, the acceleration and the mass of the body, right? Definition: if a net force acts on a body, the body accelerates. It is obviously clear, if a force is acting on a body, it produces the acceleration, right? The direction of acceleration is the same as the direction of the net force. In which direction you apply the force, in that direction the acceleration will also be produced, right? Now the acceleration is directly proportional to the force and inversely proportional to the mass of the body. What does it mean? Come to mathematically, a directly proportional to F, A inversely proportional to M. From here I write the acceleration is directly proportional to the force. Look, acceleration is directly proportional to the force, and inversely mean in fraction form, it is inversely proportional to the mass of the body. So dear student, it means that if you apply big force, the acceleration will be large. If you apply small force, the acceleration will be small. And here, if the mass of the body is larger, so there will be small acceleration. If this is small, the mass of the body is a little bit small, so acceleration will produce greater acceleration, large acceleration, right? Now combining equation 1 and 2, a taking 1a, taking 1a from these two and multiplying these two, f dot 1 over m, mean I combine these two equations. When you combine, you get this value, changing the sign of proportionality into equality. When you are changing this proportionality sign into equal sign, you must write here constant value, right, multiplied by f over m. Now dear student, in this law, the constant of Newton's second law of motion is k. So right here k, f over m, in the at the place of this constant write k. The constant is k, right? In the above equation, according to the international system of unit, if mass is 1 kg, acceleration is 1 meter per second square, and force is 1 Newton, so writing here 1 1 and 1, so the k value will be 1. The k value will be 1. So dear student, if mass is 1 kg, acceleration is 1 meter per second square, force is 1 Newton, so your constant value will be 1. Writing here 1, here 1 and here 1. So look, k equal to 1. So writing the constant value here 1, f over m. Now cross multiply ma equal to f. So this is the Newton mathematical form of Newton's second law of motion. F equal to ma is the mathematical form of Newton's second law of motion, right?